Page 12 is the last page where I'm going to have videos for you tonight. I'm going to go over the last idea here of Chapter 7, which is how to solve a linear system using linear combination. We've talked already about how to do it by graphing and how to do it by substitution. There's one other method called linear combination, and a lot of students like this method best. It's hardest to remember, maybe because the name is kind of a mouthful, but once you get into it, you'll find that it's the method that, well, it seems to work most smoothly for a lot of people. So let's say you were given this question here. 4x minus 3y equals negative 3. And the second equation is, ignore the red stuff here if you can. I'm sorry that this is written on top, but it was originally 4x plus 5y equals positive 5. Well, what I want to do linear combination is I want to find one of these two, either the x's or the y's, that I can combine. That's why it's combination, so that they'll cancel each other. Well, 4x isn't really going to cancel 4x, but 4x cancels negative 4x, so I got to change this to a negative. If I want to change that to a negative, I got to change everything in this row to the opposite sign. So the plus becomes minus here, the plus becomes minus here. If any of these had already been minuses, then they would have changed to plus. But all of these end up being changed to minuses. Now it's going to be 4x minus 4x, and that goes away. And it's going to be negative 3y minus another 5y. Negative 3 and negative 5 make negative 8y. Just like over here, negative 3 and negative 5 make negative 8. So I got negative 8y equals negative 8. Divide it away, and I'm going to end up with y equals 1. Now that I know one of the two letters, y equals 1, I can plug it back in to either one of these two equations. I ended up choosing to plug it back into the top one. 4x minus 3, well, I'm not going to say y, I'm going to say 1. 4x minus 3 times 1 equals negative 3. That's 4x minus 3 there, right? Equals negative 3. Now add that 3 to both sides, and I've got 4x. Well, when I add the 3 to this side, I'm going to have 4x equals 0. Well, that means x equals 0. And so I've got my two letters. X is 0, y is 1, and the point where these two lines, this linear system, is solved, where those two lines cross, is at 0, 1. That's it for question 3, and as you'll see on the next slide, that's the only one that I'm going to do for you on this page, because from now on the rest of the packet that I gave you says use any method you choose. So you can use graphing or substitution or linear combination, but you go ahead and finish off the rest of the ones in the packet based on these videos and the methods that I've taught you, and I'll see you in class.